In this lesson, we'll learn about the principle of physics applied to the roller coaster ride. Have you ever taken a ride on a roller coaster? If you have not, let's observe the ride. When you hear them, roller coasters could be either a scary or a fun ride. Can you imagine how you'd feel riding them? Examine a roller coaster. What keeps the coaster car moving around their tracks? Let's explore the principles behind them. Observe the roller coaster car. What happens when it is released from the top of the hill? Click the Start button to see what happens. The coaster car is moving fast down the hill. The velocity increases. The coaster car does not have an engine, but when it is released, it moves fast down the hill. Why? The force of gravity acts on the roller coaster car that pulls it fast down the hill. What happens to the roller coaster car when it climbs the second hill? Click on the Start button and see what happens. The roller coaster car slows down. Velocity of the car decreases. We know that the velocity of the roller coaster increases and decreases along the ride. Let's analyze how the coaster car moves along the path. What happens to the roller coaster car at point A, B, C, and D? From point A, the roller coaster car moves fast down the hill to the slope at point B. As the velocity increases, the coaster car accelerates at the force of gravity. At point B, the coaster car moves at maximum velocity. As the roller coaster car climbs the hill at point C, the velocity of the car reduces and it decelerates. The coaster car has minimum velocity at point D. Besides the thrill of changing speeds and directions along the track, another thrill that can be experienced is the state of free fall. Riders can experience it the moment the roller coaster moves down the top hill, when the roller coaster accelerates at 9.8 meters per second squared. Identify the path which you think the riders would experience such thrill. Let's observe the situation. We know that a roller coaster does not have an engine, and yet we have seen a roller coaster could accelerate and move around the track. Where does the roller coaster get the energy to move? The roller coaster is pulled up the hill to gain potential energy. How does it gain a large potential energy for it to move around the track? Note that the potential energy depends on the mass of the roller coaster and the height it reaches. The roller coaster is pulled up to the highest hill to gain the largest potential energy. Click on the Start button and see what happens to the potential energy as the roller coaster moves around the path. What happens to the energy level when the coaster car is halfway down the first hill? Click on the points to check on the energy level. half of the potential energy is transformed to kinetic energy. What happens to the energy level when the coaster car reaches the bottom of the hill? The kinetic energy is maximum. The car is at maximum velocity. What happens to the energy level when the roller coaster climbs halfway through the second hill? Halfway up the second hill, the potential energy is about 1/3 of the total energy, and the kinetic energy is 2/3 of the total energy. What happens to the energy when the roller coaster car reaches the top of the second hill? At the top of the second hill, the potential energy is 2/3 of the total energy, and the kinetic energy is 1/3 of the total energy. One of the thrills in riding a roller coaster is the loop. On the ride, when the roller coaster reaches the bottom of the loop, the riders will feel very heavy. Why? Let's look at the forces that act on the riders to understand what happens. Circular motion requires an inward component of net force. Assume that there are no friction and air resistance. Forces exerted upon the riders are the force of gravity at all times directed downwards, and the normal force, or we can say the force of the seat pushing up on the rider at all times directed perpendicular to the seat of the car. Click on the Start button to check on the motion of the coaster car. At the bottom of the loop, the rider often feels heavy. This is because for the net force to be directed inward, the normal force must be greater than the outward gravity force. The normal force a rider experiences when at the bottom of the loop is a large force exerted by the seat upon his body. When the coaster reaches the top of the loop, the riders are completely upside down. What happens to the roller coaster car when it reaches the top of the loop? Why do they feel very light when they are at this position? When at the top of the loop, gravity force is directed inward. Normal force is small to maintain the circular motion. A rider will tend to feel very light or almost weightless due to the reduced normal force. The normal force a rider experiences when at the top of the loop is a small force exerted by the seat upon his body. The seat almost does not touch the rider. At the end of a ride, roller coasters need a brake system for them to stop. Observe the roller coaster slowing down and stop. What kind of a brake system do they utilize? The brakes are built in the track. A series of clamps are positioned at the end of the track and at other few braking points. A central computer operates a hydraulic system that closes these clamps when the train needs to stop.
In this activity, your mission is to design a roller coaster track. Your roller coaster is expected to achieve maximum thrills without crashing or flying off the track. To begin, set the height for the two hills, the size of the loop, and the initial speed of the roller coaster car. The mass of the roller coaster car is 1,000 kilograms. Click on the Start button to see how the design works.